Hello friends, in this video we are going to learn how to apply the Lagrange method of undetermined multipliers. Okay, so I'm going to explain this using an example. I'm going to take this question using Lagrange method of undetermined multipliers. Find the minimum value of this function x square plus y square plus z square, and this x, y and z are related by this relation x, y, z is equal to a cube. Okay, so how to apply this method to determine the minimum value of this function, given function x square plus y square plus z square. Now here you see this is a function of f of this is a function of x, y and z, and x, y and z are related by this relation. Okay, so let me take this question and let me solve it. Okay, so first you see the given function is so let me take that one, f of x comma y, sorry, f of x comma y comma z. The given function is, here you can see, let me go back to the previous slide. Here you see x square plus y square plus z square. This is the given function, x square plus y square plus z square, and they're related by this relation x, y, z is equal to a cube, and it implies that x, y, z minus a cube is equal to 0. So here you see, so what is the method we are going to apply here? So first, if we have a function of x, y and z, that is f of x, y and z, right? We have a function, okay, of 3 variables, and x, y and z are connected by this relation phi of x, y and z is equal to 0. Okay, it is a function of x, y and z, and connected by this relation. X, y, z are related by this relation. So in that case, what we are going to do, that then we have to solve these 3 equations. Del f of del x of f, that means del f by del x, plus lambda into del phi by del x is equal to 0. Similarly, del f by del y plus lambda into del phi by del y is equal to 0. Then del f by del z plus lambda into del phi by del z is equal to 0. We need to solve these 3 equations, right? And solving these 3 equations, we need to obtain value of x, y, z and lambda. Okay, then we're gonna put that values, okay, these values here. We're gonna use the value of x, y and z in this function. Here we're gonna put the values, okay, so to get the minimum value of this function, right? So let me show you that how to do. So first, what we are to do here, so here this is the equation phi of x comma y comma z is equal to 0. Okay, if you compare with that, then here we have got phi is equal to x, y, z minus a cube. This is our phi, right? So now del f by del x plus lambda into del phi by del x, okay, is equal to 0. So let me find the equation first. So what is the equation here? in this case. You see, if you differentiate this f with respect to x, then these two are regarded as constant, as we are doing partial derivative. So derivative of x squared, that's going to be twice x, right? Then plus, now lambda into, now differentiate this with respect to x, right? Then what you will have here y and z should be taken as constant. Derivative of x is 1, so that's going to be yz, and derivative of this is 0 again, right? And that's going to be equal to 0. That's what we have got now, right? Now you see here, now let's find del f by del x, sorry, not del x, del y plus lambda del phi by del y. Then what you're gonna get? Again, differentiate this with respect to y, then you're gonna get 2y, then plus lambda. From here, differentiating this with respect to y, you're gonna have, x z is equal to 0. And similarly, just wait, so it should be equal to 0. This implies this one. And del f by del z plus lambda del phi by del z, that's going to be equal to 0. And it implies, now differentiate this with respect to z, and this one also with respect to z. After differentiation, what we're going to have, 2z plus lambda, then here xy is equal to 0. That's what we're going to have. Now let's do one thing. Now you see, we can write this equation this way: twice x is equal to minus lambda yz, and this equation can be written as twice y is equal to minus lambda xz, and twice z can be written as minus lambda xy, right? And let me copy these three equations and let me go to the new slide. Let me take a new slide, and here is the first equation, and next one is this. Let me copy the next equation as well. So here is this, and then the last one is this one. This is the last equation. Just wait. So this is suppose 1. Just wait. Let me give this one as 1, equation number 1, and let me take this is 2, and this is 3, and this is 4, right? Let's find, let's divide 2 by 4. Equation number 2 by 4, then what we're gonna have, twice x by twice y, 2 to cancel, x by y, and from here we're gonna get, if you divide this one by this, then z will be cancelled, right? And lambda minus lambda will be cancelled, and then we're gonna have y by x, and similarly dividing sorry, here I have done 2 divided by 3, actually equation number 2 divided by 3. Now dividing 3 by 4, what we're gonna get, we're gonna get y by z, and that's gonna be equal to z by y. That's what we have got, right? This implies x square is equal to y square, that means x is equal to y. Similarly here, y square is equal to z square, that means y is equal to z. Therefore what we're gonna get, x y is equal to z, both are equal. This is equation number suppose 5. Okay, now using 5 in 1, okay, if we use this x y z in 1, this is in this equation. So what was equation number 1? Equation number 1 was x y z is equal to a cube, right? So instead of y and z, let's put x. So that's going to be x cube is equal to a cube, which is equal to which implies x is equal to a. So if x is equal to a, that means we can say x is equal to y is equal to z is equal to all equal to a, because all the three variables are equal. So using therefore minimum value of the function, therefore minimum value of f of x comma y comma z is nothing but f of x should be replaced by a, y should be replaced by a, and z should be also replaced by a, and who is going to be equal to, let me go to the next slide. Okay, so we know that f of x comma y comma z is equal to, this is given that x square plus y square plus z square, right? This is given. So if you put a, let's put here a, here also. So putting here we're gonna have a square plus a square plus a square, which is gonna give you 3a square. This is the required minimum value of the given function. So hope you have understood this. If you have understood, please subscribe the channel and do share with your friends, inspire me to create new contents for you. So thank you for watching. See you in the next video. Bye bye.